The next operation, multiplying two matrices, is a little bit tricky. So let me just begin with a simple example. Let's continue to use this matrix A. Notice in this case, matrix A is a 2 by 2. By the way, there's clearly should be a space between that -3 and the 2. Okay. Some writers will put a comma between the elements to separate the elements, but more generally, you just leave a space, and then that means this is the next element. So let A be that matrix. Let B equal this matrix. B is also a 2 by 2. Now, the first thing you need to do is check the dimension of each matrix. And probably the best thing to do is just write them next to each other like this, A, B. Notice A is a 2 by 2. B is also a 2 by 2. You can perform matrix multiplication. The operation is defined only when the number of columns of the lead matrix, A here is the one that comes first, so it's said to be the lead. You can perform matrix multiplication only when the number of columns of the lead matrix is equal to the number of rows of the lag matrix. Now, the simplest way to remember this is just write down the two matrices in the order in which the multiplication occurs, and then check to make sure that these two inner numbers are the same. These two are both 2's. So that means you can perform the operation. If those two numbers were different, then you could not perform matrix multiplication. Okay. For example, if this B matrix were a 3 by 2, you couldn't calculate A times B. If this number were anything but 2, you couldn't perform the operation. The number of columns in the lead matrix has to be equal to the number of rows in the lag matrix. Okay, so that's one advantage of writing the two matrices like this. The second advantage is you can immediately tell the dimension of the resulting matrix. Let's call the product matrix over here on the right matrix C. Then the dimension of matrix C will be the two outer numbers, 2 by 2. Okay. So, all right, how do you do matrix multiplication? Well, let me just write these two matrices next to each other. Okay. There's a little bit of a space, but that's okay. We're multiplying A times B. What I suggest you do is take the first row in the lead matrix. Okay. Then what you're going to do is multiply that row times the first column of the lag matrix. And you multiply it in this way. You multiply 1 times -1 plus 0 times 2. And that will give you the element in the product matrix, first row, first column. So if we do that, let me write it again. 1 times -1 plus 0 times 2. That sum, will be the element in first row, first column of the product matrix. Okay. Then next you go, you continue with this row, but you multiply it times the second column of the lag matrix. And when you do that, I'm going to leave a space here because we're moving on to this next element. It'll be 1 times 2 plus 0 times 5. Okay. Now, there are no more columns in the lag matrix, so we're done with the first row. So then you go to the second row. Let's circle that. And you multiply that second row times the first column. Doing so, we get minus 3 times a minus 1 plus 2 times 2. Okay. Then we multiply the second row times the second column to get the last element, which will give us a minus 6. Oops, I don't want to do that multiplication in my head, sorry. It gives a minus 3 times 2 plus 2 times 5. Okay. Now we sum them. Sum these elements. We know we're supposed to get a 2 by 2, so it checks out. Okay. So this will be a minus 1 plus 0, be a minus 1. This element right here. This element right here will be just 2 plus 0 is 2. This element here will be what? 3 plus 4 is 7. And this element here is minus 6 plus 10 would be 4. Okay. So this is the product matrix over here.